Hey there, everybody. Welcome back. We're going to continue chapter 4. We're going to do 4.2, and this is factoring by grouping. And we actually had a little bit of a segue to it in the last second. Look how bad I just gained ink all over myself while I'm writing. It's crazy. All right, so recall how in like the last section, we had like 4z with 3z plus 2, and then we had 5, and we had 3z plus 2, and we ended up making that 4z plus 5 in parentheses times 3z plus 2. That's what we did. Well, what if we don't start with something like this? What if I started with 12z squared plus 8z plus 15z plus 10? Now, I probably wouldn't see it this way. I would probably see it like this. But we're going to take a look at this in 4.4, which is the next video I'm going to do. I'm skipping 4.3. We'll come back to 4.3 after 4.2. So 4.4 is starting here. We're just going to say we start here. When you've got 4 terms, the idea is to pair them up and see if they have an individual common factor. Okay, and then, so like 12z squared plus 8z. And then I'll do 15z plus 10. We already know where this is going because we can see what it factors to. But what I'm going to do is just treat it like this, and then we'll go on to a harder one. This is 4 times 2, and this is 4 times 3. If necessary, do 2 times 2 for both if you don't recognize them right away. This has got 2 z's, and this has got 1 z. So the GCF is 4z. So this one, I'm going to take out a 4z, and what I'm left with is a 3z plus 2. And I do the same thing down here. I make my table. This is 5 times 3, and this is 5 times 2. This has got a z. The greatest common factor here is a 5. So these are both plus. I'm going to do a plus 5, and I'm left with 3z plus 2. Okay? That's how it's going to go. And then we finish factoring and pull out, like we did at the end of the last section, pull out the 3z plus 2, and we're left with 4z plus 5. And this is why I put a slash on my z's. Look how close my z's and my 2's look. Okay, so little quick list of stuff you might like. So we're going to arrange terms so that each pair has a common factor. Then we're going to factor out the GCF for each pair. And we're going to check. Okay, if what's left over is the same, we finish factoring. Like we did up here. We pulled out the 3z plus 2 was the same for both of them, and so we're able to finish factoring. And if they don't match, try a different pair. Try rearranging. Sometimes that helps. And finally, if none of those combinations work, it doesn't factor further. Or at least factoring by grouping doesn't work. That's probably the better thing to say. It might factor further, but factoring by grouping. And none of these combinations work. Factoring by grouping doesn't work. There we go. We're going to go with that. All right. Examples. First example. One where we don't know what it has in common. We've got 3axy plus 2bxy plus 15a plus 10b. So I'm going to pair them up and I'm going to leave them. I can see they both have an x and a y, so I'm going to pair them up as is, see if it works. If you need to, make the table. XY is the GCF, and I'm left with 3a plus 2b. Second set, I see I got 3 times 5a and 2 times 5a. Oops. That's not an A, that's a B here. So the only factor there is the 5. And I'm left with, that had an A in it. I'm left with 3a and 2b. All right, now these match. So I can pull that out. And I'm left with xy plus 5. That's what goes in the second parentheses. And that's factored. All right. Let's go on. Next one, I need to show you one more thing. And then we'll have you try some of these on your own. My black pen is running low. All right, we're going to go by pairs. This is 3 times 3 times 3 times x squared. Nope, only 2 3s. This is 3 times 3 times 3. So the GCF here is 9. And I'm left with x squared plus 3. Now, this is negative, so I'm going to factor out a negative out of everything. That's the big difference. If there's a negative, factor out a negative, which means whatever I have is going to have a plus on this one because the minus gets factored out here too and leaves behind a plus. 2 times 3, and this is 2 times 3 times another 3. and that's got an x squared. The GCF is only 3. I'm left with 2x squared. Nope. There's a 2 also. What am I doing? GCF is 6. There is an x squared and a 3. All right. I have the x squared plus 3 in common. We're going to pull that out. And I'm left with 9 minus 6. 9 minus 6 is 3, so I'm just going to do that. This is 3 times x squared plus 3. Could I have done this from the beginning? Yes, I could have. I could have combined these together, the 9x squared and the negative 6x squared. And I could have combined the 27 and the 18. Let's see. All right. Next one, xy minus 5y minus 2x plus 10. It looks like I can see these only have a y in common. And if I pull out a minus 2, 10 divided by minus 2 is negative 5. So I finished putting them together. I have x minus 5 times y minus 2. Bring out another black pen for a little bit. All right, next one. You guys start giving these a try. I'll put 3 of them up. Pause the video and work those out. All right, I'm going to assume you did. It looks like between 4a squared and 5ab, they both have an a. This has a 4a left, and this has a 5b left. Here, I need to pull out a minus. So I'll have a plus in here after I'm done. I've got 10b and 8a. These both have, they're multiples of 2. That's got an a and that's got a b. So I'm pulling out a 2. And I'm left with 5b and 4a. Are these the same? Yes, they are. When we have a plus, we can swap orders. and make that 4a plus 5b. So I have 4a plus 5b in common with both. What I have left over is a minus 2. And we'll give this a gander here. 6ax and 3bd both have a 3 in common. This has a 2ax left, and this has a bd left. These two, shit, they don't have anything in common. So this combination, these two as pairs, don't work. Maybe let's rearrange it so that we've got, this is an ax. We can either put it with the a or we can put it with the x. Let's try putting it with the a. So I'm going to rearrange this real quick and have 6ax minus 2ad plus 3bd minus 9bx. Now when I factor, I have a 6a and a 2a. It looks like 2a is what's common there. So I'll pull out a 2a, and I have 3x minus 3 left. Oh, there's a d there. 3x. No, there's no 3 there, though. 3x minus d. There we go. And now if I do these here, if I want an x first, maybe I should change the order of these. I want a 3x minus d. Maybe I should put the minus 9bx first. Let's try that. That way, when I factor out a negative, I'm left with a minus inside. So we're going to rearrange those two real quick. Here, they both have 3b in common. The 9bx has a 3x left. The other one just has a d, which is what we wanted. 3x and d. And we factor out a 3b. So the final factored form is 2a minus 3b times 3x minus d. And it doesn't matter which one I put first. The other ones, I was putting the parentheses ones first, but here I put the stuff out front first. If I multiply it all out, I will get these 4 terms on top. Here I had to rearrange it because the original pairing wasn't all that good. Okay. One final pairing, 4x cubed and 4x squared. They both have a 4x squared, don't they? And that's got another x. So that's my GCF. And I'm left with an x plus 1. Here I'm going to factor out a 20, or a minus, sorry. I've got 20x and 5. The only thing they have in common is the 5. So I'll factor out the 5. I'm going to factor out the minus with it, which leaves a plus inside. And I'm left with 4x and 1. And that didn't work, did it? So let's try a different pairing. when you have something like this where it doesn't work the way you want, these don't match. See that? They don't match. So what I'm going to do is I'm going to put the first and the third one together. And we'll try this again. We'll do the first two together and the second two together. This doesn't have anything in common, does it? So that's going to have to be a 1. If I factor the top one, or the first pair, they have a 4x in common. And this has an extra x squared, and this has a 5. So they both have a 4x, and this has an extra x squared. And we've got minus 5. Now we can put them together because now these match. Wait. No, they don't. They still don't match. Isn't that right? Does this not factor? It may not factor. Let's try putting, we've tried the 4x cubed with the 4x squared. We've tried this one with this one. If I do the 4x cubed with the minus 5, it's not going to do anything. This actually doesn't factor. Apparently doesn't factor by grouping. Interesting. All right. I wouldn't have guessed that by looking at it. That's it for this video. Peace.